All right, so we are going to look at trig functions of any angles, and actually we've done this a little bit because we've done it on the unit circle, and we've looked, like at 3 pi fourths. So 3 pi fourths is not an acute angle, so it's going to be kind of similar to that, but just getting you used to that unit circle and finding all these angles. So we're going to do a little bit more work with that today. Let's take a look at this first slide, and I put that on there. We're not going to restrict it to just acute angles. So let's say that theta is an angle in standard position. Okay, so let's write that out. Theta, angle in standard position. I'm not sure where that double circle came from. So theta is just a circle with a line through it. I must have clicked my pen and it automatically made another one or something. And let's say that the point xy is a point on the terminal side of the angle. So the terminal is the ending side. Let's draw one then that is no longer in the first quadrant. So we have an angle in standard position. So it starts at the positive x, and we're going to travel counterclockwise over to here. So there's our terminal side. Our point right here is just the point x, y. And this angle in standard position then is theta. All right. When we, like if I go from that point, the xy, and I draw down the perpendicular, so I know I have a right angle here, then this side of the triangle, because I'm going left, that's our x value, but it is going to be a negative x because I'm going left. And then the y value is going to be a positive value. Now, I'll keep this point here, xy. So you just have to know it says any point xy, so it means the x could be positive or negative, the y could be positive or negative, depending on where you happen to be. Because my xy just ended up being in that second quadrant. The x is negative, the y is positive. All right, in order to figure all the trig functions then, I also have to take into account the length of the radius. So this, let me draw it in another color. So this distance right here, we'll let be r. So if I know the x and the y value then, which are the legs of a right triangle, I simply do the Pythagorean theorem to find the length of r. So r is the square root. So instead of going r squared is equal to x squared plus y squared, I'll do the square root of x squared plus y squared will give me r. And always remember that our r is always going to be a positive number. So going left or down will create negatives, but the r, regardless of what quadrant it is in, the r will always be positive. So if I set up then, let's go back to blue. Let's say that I'm looking at angle theta, and I want to find the cosine of that angle. Well, what we do then is we look at the little triangle here that we have built. Sorry, ELO is over. And I'm going to use the triangle then that I have positioned in that second quadrant. So the cosine is the angle, is the length of the adjacent side over the hypotenuse, and our hypotenuse is r. Now I'll just put an x here, but remember when you go to find that angle, your r is always going to be positive and your x is always going to be negative. So the cosine of any angle in that quadrant is going to be a negative number because your x is going to be negative. All right, if I wanted to look at the sine of the angle in relationship to the angle, so I'm looking at the little triangle then. So my sine is opposite over hypotenuse, so it's going to be y over r. And the sine, well, r is always positive, and in that quadrant, the y value is always positive, so the sine is always going to be a positive number. And we'll talk a little bit more about that in a little bit. And then let's go ahead and do tangent, the tangent of the angle then. I'm referring to the little reference triangle here. So we're looking at this angle then. So to get the tangent, it's opposite over adjacent. So it's y over x. And then remember that your reciprocal ones are just the opposite. So if cosine is x over r, then secant of the angle is going to be r over x. The cosecant is the reciprocal of sine, so this will be r over y, and cotangent is the reciprocal of tangent. So that's how we come up with these. We can find all of these angles. They don't just have to be acute angles. All right, let's try this problem then. So what we're going to do is draw coordinate axes, and we're going to label the point 3, -4. So 3, -4 is going to put me in the 4th quadrant. So I'll kind of draw it lopsided because I'm just looking at the 4th. So I'm going to go 3 units to the right, and I want to go 4 units down. So my point 3, -4 would be right here. So that's on the terminal side of an angle in standard position. So that blue ray that I just drew is my terminal side. So standard position means I start over here at the positive x and I wrap all the way around to that side. So that angle is going to be our theta then, if we label it. I think it always helps to draw in this little triangle. Keep in mind then, this side here is 3 because I went 3 units to the right, and then I went down 4, so I'll put a -4 here. In order to find the sine, the cosine, and the tangent, I'm going to have to know all 3 sides of the triangle. So we're going to, because it's a right triangle, we can use the Pythagorean Theorem. 3 squared plus 4 squared is 25. Square root of 25 is 5. Some of you might recognize the Pythagorean triple, 3, 4, 5. So I knew the 2 legs, so the hypotenuse is 5. Once again, the hypotenuse, that length, the r, is always positive. So even though I am in the 4th quadrant, and I'm kind of drawing that terminal side down, it's still a positive length. So the only negative is associated with the 4 because I'm moving straight down. All right. Now we're looking at this angle then, and in relationship to that angle, the sine of the angle is opposite over hypotenuse, so it's a -4/5. Whereas the cosine is the adjacent over the hypotenuse, so that's positive 3/5. And the tangent is opposite over adjacent. So those are the 3 trig functions of that particular angle. Now, we want to find the sines of the trig functions in the 4 quadrants. All right, so let's just draw a big axis here. This is quadrant 1, and then 2, 3 and 4. In the first quadrant, any angle that we draw that has a terminal side in the first quadrant is going to be an angle that measures less than 90 degrees, or pi halves, and greater than 0. So 0 to 90 degrees, 0 to pi halves. In the second quadrant, our angles are in between pi halves and pi. So they're in between 90 and 180. In the third quadrant, all the angles whose terminal sides end up there are between pi and 3 pi halves. And in the fourth quadrant, they're in between 3 pi halves and 2 pi. 0 to 90, then 90 to 180, 180 to 270, and 270 to 360. All right? When we do the ordered pair, like in the first quadrant, we know that when we label ordered pairs, the x value is going to be positive, so is the y value. All right, so if I drew a little triangle then, let's do it in red. This is the x, this is the y, this is the r. So I'm going to the right for the x and I'm going up for the y. So therefore it's positive and positive. All right, well if that's true, to get the, if I'm looking at this angle, this is going to be our theta. The sine is the opposite over the hypotenuse. Sine is the y value over the r. The y is positive, the r is positive. So that means the sine of an angle where the terminal side is in that first quadrant is always going to be a positive number. The cosine is the adjacent. Notice the adjacent is the x value. So the x value over the r. So the r is always positive, so really I can just look at the values of x and y. So because my x is positive, my cosine, which represents the adjacent side, is always going to be the side that lies on the x-axis. So it will be positive. Tangent requires both the x and the y, so it's opposite over adjacent. And so the y and the x are both positive, so therefore y over x will also be positive. So really, we can just look at the x and the y values. So in the second quadrant, my x is negative and my y is positive. So I'm going a negative x and a positive y. Okay, so the sine is going to be, the opposite is going to have the y, so it's positive. So the sine of any angle whose terminal side ends up in the second quadrant is going to also be positive. Whereas the cosine, I'm using the x value, and it is negative. And tangent, I'm using both the x and the y. So a positive and a negative together give you a negative. In the third quadrant, we're going left and we're going down. So both of the x and the y, or the adjacent and opposite sides, are considered negative. In the third quadrant, any angle that has a terminal side that ends up in the third quadrant, to find the sine, we're going to look at the opposite, which will be the y, over the r. So the y is a negative. So it means our sine will be negative. Whereas the cosine, we use the x value, which is negative, and tangent, we use both the x and the y. So negative divided by negative is positive. And in the fourth quadrant, we're traveling to the right, so our x is going to be positive, and then down, so our y is going to be negative. So for the sine, we use the y, so it's negative. The cosine, we use the x, so therefore it's positive. And the tangent, we use both of them. So it will once again be negative. All right, so sine is positive in the top two quadrants, the y value, because you're going up. So the sine is positive, whereas in the bottom two quadrants it's negative because it's associated with the y value, which we move down. The cosine is positive in the first and second quadrants because we use the x value and we're going to the right. So when we go to the right, it's a positive value. And in the second and third quadrants, it's negative because for the x value, we travel to the left, which makes it negative. And then the tangent, then we use the two of them. So when we have opposite signs, then we're going to have a negative tangent. And when we have the same sign, like the sine and cosine are both positive, or the sine and cosine are both negative, then the tangent will be positive. So tangent is positive in the first and third, negative in the second and the fourth. Let's say that they tell us the tangent of the angle, and we need to find the sine and the secant. Well, they say the tangent is a negative 3/2. Well, we just talked about the tangent being negative in both the second and the fourth quadrants. So, sorry, let's get this. Let's just draw a little axes right here to begin with. So tangent is negative down here. It's also negative here. So I need a little more information because I wouldn't know if it's between 90 and 180 or 270 and 360 degrees. Then they tell us that the cosine is also greater than 0, so where the cosine is positive. Well, the cosine is positive in these two quadrants. So where they overlap, we're looking at an angle in this quadrant, then in the fourth quadrant. So let's draw out our triangle. And we just want to concentrate on the fourth quadrant. They tell us the tangent. And I'm just going to draw the triangle to begin with, and so it's not necessarily to scale. But the tangent of an angle is the ratio of the opposite over the adjacent. Okay. I'm looking at, remember, this angle, but we're looking at this little triangle over here in the fourth quadrant. So the opposite side is this side right here, and the adjacent is this side here. So it's along the positive x. So if my tangent is negative 3/2, that means I'm not sure which one is negative, so we just look at the 3. We say, okay, the opposite is 3, so here's my opposite side. The adjacent is 2. Then you look to see where you're placed, what quadrant you're in, and I'm going right and down, so it is indeed the 3 that's the negative, and the 2 is the positive. All right, so now that I have two sides, I can use the Pythagorean Theorem to get the length of the hypotenuse. So 2 squared is 4. Negative 3 squared is 9. I add them together, I get 13. So that's what r squared is equal to. So that means r is equal to positive square root of 13. The r is always positive. Now I have all three sides of the triangle, so now I can find any of the trig ratios. It asks specifically for sine. So the sine of the angle is the opposite, so negative 3 over hypotenuse. And then remember, we would just change that out. We'd multiply by the square root of 13 over the square root of 13. So I'd get negative square root of 13 over 13. Whereas the secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So the hypotenuse is square root of 13. The adjacent is 2. So the secant of the angle would be square root of 13 over 2. Now for the trig functions of the quadrant angles. And these we wrote these on the plates, and we just wrote them as ordered pairs, so we haven't really talked about what they represent. So on our plates that we made, the unit circle, we are going to move out. Our radius is 1, so r is equal to 1 here. So we said this ordered pair right here is the point 1, 0. Then up here, if I go up a length of 1, this point is 0, 1. Here, if I go to the left one, we've got negative 1, 0. And if I go down 1, I get 0, negative 1. Okay, what those ordered pairs represent then is the sine and the cosine of an angle. So let's just start off with the cosine of 0 degrees. Okay, so I know my r is 1, I know my x is 1, and my y is 0. So the cosine of 0 degrees is the x over the r. My x is 1, my r is also 1. So the cosine, oh, I put a theta, so the cosine of 0 degrees is 1, 0 degrees. The tangent of 0, the tangent is the opposite over the adjacent, so the opposite is the y. So the tangent at 0 is going to be the y value over the x value at 0. So it will be 0. The sine at pi halves, which would be this angle here, 90 degrees. So I'm looking at these points here. So sine is the y over the r. So the sine is 1. The sine at pi halves is 1. Whereas the tangent at pi halves, the tangent is the y over the x, so 1 over 0. Oh, I can't divide by 0. So the tangent at 90 degrees or pi halves is undefined. All right, so think of your x, y, and r values to help you out with this. Let's do the cosine at pi. Okay, so at pi, my x value, so right here, maybe this would help. My x is negative 1, my y is 0, and my r is still 1. R is always, always 1. So to get the cosine, we use the x over the r. So I get negative 1. The sine of 3 pi halves, the sine is the y, so I'm down here, I'm looking here at 3 pi halves. My y is negative 1, my r is 1. So the sine at 3 pi halves is negative 1. And then let's also do the tangent down there. The tangent at 3 pi halves. Tangent, I use opposite over adjacent, or y over x. So negative 1 over 0. Oh, that one is also undefined, just like the tangent of pi halves. So that's how you find those. So you're looking at your x, your y, and your r, and then you could figure out all of those. So for example, if I know the sine of pi halves, the reciprocal of sine is cosecant, so the cosecant is the reciprocal of 1, and the reciprocal of 1 is still 1. So the cosecant, oh, I forgot my angle, at pi halves is 1. Okay, so that's how we find the different trig functions on the quadrants. So they call them quadrant angles because the terminal side ends up right on one of the, like at 90 degrees, 180, 270. So that's why they refer to them as that. Okay, and the last thing I want to look at, see this is getting longer than I wanted it to, is reference angles. And a reference angle is an angle in standard position. So if theta is an angle in standard position, then the reference angle is the angle formed by the terminal side. Angle formed by the terminal side of theta and the horizontal axis. All right, so in the first quadrant, an angle in standard position. Maybe it might look like this. So this is theta. Okay. So if theta is here, it's the angle formed by the terminal side. So here's the terminal side and the horizontal axis. So this angle then is my reference angle. So in the first quadrant, your angle is simply your angle. Okay. In the second quadrant, yeah, it might be easier just to make a separate little. So if I have an angle in standard position, but the terminal side is in the second quadrant, so here's our theta. The reference angle is the angle that's formed by the terminal side, so this is my terminal side, and the horizontal axis. So it's this little angle right in here. In the third quadrant, so I want an angle in standard position, but I want the terminal side to end up in the third quadrant. That terminal side is right here, and I want the angle formed with the horizontal axis. So it's right there. And last but not least, if I have an angle in standard position whose terminal side ends up in the fourth quadrant, then I want the angle formed by the terminal side and the horizontal axis. So that's the angle. So notice how all of the reference angles are from the terminal side and the horizontal axis. So you never see it back to the y, it always goes to the x-axis. Okay, and that's how we find reference angles. All right. Well, I think that's all we're going to do for now. There's a few more things in that section, but we will just have to hit those in class. All right, good job.